Okay, I'm looking from the packet that I gave you all on Thermo. And so I wanted to go over a concept on page 6. Okay? I want you to look at a concept on page 6. And what we have there basically is we have a graph, pressure versus volume, and we've got a line that goes there, another. These are all isotherms. And we're going to take a gas through a cycle. We'll go through this cycle, A. We're going to go from this cycle here along. We're going to call that B. And then we're going to go from here straight down. Notice I said straight down. That's C. Then we're going to go to cycle D, from one isotherm to another. Okay? So again, this is on page 6 of the packet that a friend of mine, Chris Brune, wrote. Excellent. Excellent. And so one of the things he wants us to go through as we go through this is he wants us to fill in a chart, path A, B, C, and D, for each of these different values, delta T, delta U, W, and Q. And in order to fill in this chart, and the reason it's worth doing is a lot of times questions that they give you on the AP test are just simply, if you can fill out one of these charts as you go through it, you can figure out what they want. So, only things you need to remember, a few concepts. Anytime, if we have a low value of P and V from the equation PV equals nRT, if we go from this part of the PV diagram to this part, anytime we're going this way, our PV is increasing, which means our temperature is increasing. And if our temperature increases, if delta T goes up, then delta U goes up. So whatever this does, this does. Alright? And then the only other equation you need is delta U equals Q plus W, one of our laws of Thermo. And so let's look at the situation and figure it out for each of these examples. Let's start with A. I'm starting on this isotherm, and I'm going to this isotherm. So this, again, this dashed line is all the same temperature. And so I'm going from here to here. So what's happening to my temperature? It's increasing. So this is positive. And so if delta T is positive, that means delta U is positive. So now what about work? Well, let's just look from here to here. If I were to just make a graph and find this area underneath this graph of just from here to here, that area, is the gas expanding or contracting? Well, the volume is getting bigger, so the gas is expanding. And if the gas is expanding, is it doing work or is work being done on it? It's doing work. And so if it's doing work, it's losing energy, so that's negative. So W is negative. Well, if delta U is positive and W is negative, then what's Q going to be? Well, if this is positive and this is negative, then that means that has to be positive, doesn't it? Because this plus a negative has to equal positive. So this Q is positive. In fact, it's got to be a big positive, doesn't it? I'm going to write a big positive right there. There's pressure. All right, let's look on B. I'm starting here at B, and I'm going up the isotherm. So if I'm going up the isotherm, what's happening to my temperature? Well, if I stay on my isotherm, my temperature is not changing. Well, if my temperature is not changing, then that means delta U has to be what? Whatever this does, this does. Because if this is 0, this has to be 0. So if my delta U is 0, so now the next thing we have to ask ourselves, what about W and Q? Well, is work being done on the gas or by the gas? Well, the gas is being contracted, so that means the gas is being smushed. If the gas is being smushed or compressed, that means work is done on the gas because the volume is getting less. And so if work is done on it, then the energy, so then it gains energy, so that's positive W. Well, if this is 0 and this is positive, then Q has to be what? negative. So you have to be losing energy to go from there. All right, now let's look at part C. Part C, I'm going from this isotherm, higher PV value, a higher temperature to a lower isotherm, so my delta T is negative. And if this is negative, then according to this equation, delta U is negative as well. All right? Well, what about the work? They love to ask this question on the graph. They show you a PV graph, and they have a line going straight down and how much work is done. No work is done. Why is no work done? There's no area. P delta V, there's no delta V's. Work is P delta V, so the work is 0. So this is 0. So, if delta U is negative and work is 0, what's Q have to be? It has to be negative. Alright? So heat is being removed from the system, but not by work. But the temperature is dropping. Now let's go to point D. Now we're on a, what's that word if the pressure is the same? Isobar. So I'm on point D, and I'm going from a higher isotherm to a lower temperature isotherm. So my delta T is negative. So that means my delta U is negative. Well, if delta U is negative, now let's look at work. Is work being done on the gas, or is work being done by the gas? Well, if it's being compressed, then work is being done on the gas because the volume is decreasing. So that's negative work. So if this is negative and this is negative, then Q has to be, let's see here, hold on, time out.